In this video, we're going to take a look at one of the most common interview questions that you can probably be expected to see asked about binary search trees. Now, unfortunately, this is also a pretty challenging problem. So in this video, I'm going to lay out a couple of general pointers, and then you should give the problem a shot, and then we'll take a look at the solution as usual. But on this one, if you don't come up with any progression pretty quickly, don't sweat it, just take a look at the solution. Again, this is a rather challenging one, but it is a problem that you should definitely know how to do. All right, so inside of my project directory or my code editor, I'm going to find the validate directory, and then I'll open up the index.js file inside there. And then as usual, we'll also flip on over to the terminal and run just validate -- watch, like so. And we should see 2 tests running right now. Yeah, 2 total. All right, so let's look at the directions here and see what's going on. So we're going to be given a single node out of a binary search tree. Presumably this is going to be the root node. Our job is to validate the binary search tree. In other words, we want to make sure that every node's left-hand child has a value that is less than the parent, and every right-hand child is greater than the parent. Now, at first glance, this might look like a rather easy question, and it might look very similar to the insert method that we were just working on. You might be thinking, okay, well, we can just recurse through the binary search tree, and we'll check every value against something else. I don't know, make sure that every child is on the left-hand side is less than the current node's value, make sure every child on the right-hand side is less than the current node's value, and that's pretty much it. Well, unfortunately, it's going to be a little bit more challenging than that, and let me show you why. So when we were just working on our insert question, we saw that we could look at each individual node and we can do a simple comparison to say, okay, maybe we're trying to insert 15 here. We'll start off at 10. 15 is greater than 10, so we would move to the right. 15 is greater than 12, so we'd move to the right. 15 is less than 20, so we move to the left. And then 15 is less than 17, so we again move to the left. And for the insert question, that wasn't the worst thing in the world. We were able to simply iterate through and only ever consider the current node, like just this node. And we didn't have to worry about anything else. But remember, the point of this question is to validate a binary search tree. So we kind of have to assume that there might be something very wrong with the search tree that we are being passed. So let me give you an example of how a binary search tree might be very wrong. Maybe we would take this 15 and maybe for some crazy reason, it would end up over here on the right-hand side of -1. Now this kind of poses a problem, and here's why. When we were putting together insert, we were only ever looking at this one current node. And we said, okay, is this value greater than or less than the current node? In this case, you and I could look at this and say, okay, 15 is greater than -1, so hey, 15 is on the right-hand side. It's in the correct location. However, it's not actually in the correct location when we consider the overall structure of the tree. So it's on the right-hand side of -1, it's definitely in the right spot here, but it's not in the correct location looking at the whole tree. Remember one of the properties of binary search trees. We have the root node up here at the very top, and we've said many times that the child elements to the root node, anything on the left should be less than, and anything on the right should be greater than. But by extension, that same exact rule also applies to the left and right's children as well. So notice how children of 10, anything on the right-hand side should always be greater than the root node. So everything on the right-hand side is greater than the root node. And in theory, everything on the left-hand side should be less than the root node. However, in this case, we have 15, which is greater than 10. So 15 is violating the rules of a binary search tree, not only because of the root node up here at the top, but also because of the 0 right here. 15 is to the left of the 0. See, we travel from 0 to the left-hand side. That means that it's on the incorrect side relative to both 0 and 10. So that's the real issue here. We are picking up this 15 value on the completely wrong side of the binary search tree. And the reason that's kind of a pain is that it means that our simple method that we just use for insert, where we just look at the current node and then say, okay, is this less than or equal to the current one, doesn't really carry well over to this whole kind of validate thing. So that's the big challenge. That's why this one is hard. We have to consider not only the immediate parent node, but essentially everything above that as well. All right, let's take a pause right here, and then we'll talk about one possible solution to this, and then I'll cut you loose to work on the problem on your own a little bit. So quick break, and then we'll talk about solution in the next video.